Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome you all students for our chemistry lecture, chapter number 7, that is modern periodic table. In our previous lecture, we have completed electronic configuration of elements in periods. We have done the electronic configuration of element for the first period, second period and third period. Today we are going to move further. Let's start, student. The fourth periods begin with filling of 4s subshell. Usually the fourth period will containing how many numbers of shell? It is 4, and the fourth S subshell will be the first one. The first two elements of the first periods are, who are the first two elements? It is potassium and calcium. Potassium atomic number is 19 while calcium atomic number is 20. So its electronic configuration for potassium is AR. AR, that is your noble gas elements, argon. Then till argon 18 electron has been done. How much is remaining? 1. So argon 4s 1. Then calcium atomic number 20. Argon 4s 2. Further, after argon, potassium and calcium, other elements comes in the fourth period. So according to the Oprea principle, the next higher energy subshell is 3D. Fine. We have done Oprea principle in a previous lecture. 1s, 2s, 2 like this way. We have done 2p, 3s, so on. So here, according to the Oprea principle, the next higher energy subshell is 3D. Now the electron will move in the 3D subshell, which can accommodate how much electron? It can accommodate 10 electron. So filling of the 3D subshells result in the next 10 elements of the fourth period. So now the further 10 elements will move their electron in the 3D subshell. So from scandium to zinc, the electron will move to 3D subshell. Scandium atomic number 21. Its electronic configuration argon 4s2 3d1. After scandium, titanium, vanadium, magnesium, copper, iron, so on. Okay, so like this way it will move towards zinc, whose atomic number is 30, and its electronic configuration is 4s2 3d10. After the completion of 3d10, now the electron enter the subshell 4p for the next 6 element. GAZ, whose atomic number is 31, to Kr, krypton, whose atomic number is 36. So atomic number 31, its electronic configuration will be Ar, argon 4s2 3d10 4p1. 2. Krypton, atomic number 36, electronic configuration Ar 4s2 3d10 4p6. So the fourth period does contain in all 18 elements. How 18 elements? 2 for the 4s subshell, 10 for 3d subshell, 6 for 4p subshell. Okay, as we know, the S subshell containing maximum 2 electron, D subshell containing maximum 10 electron, P subshell containing maximum 6 electron. So 2 plus 10 plus 6, how much it totals? It is 18. So the fourth period does in all containing 18 elements. Now we are moving forward towards the fifth period. Similarly, how we have done for the fourth periods. First, the element will enter in 4s, then 3d, then 4p. Here also, the fifth period accommodate 18 elements as a result of successive filling of electrons in the 5s, 4d and 5p subshell. 5s 2 electron, 4d 10 electron, 5p 6. So 2 plus 10 plus 6, it is your 18. Fourth period accommodate how much elements? 18. Similarly, fifth period accommodate 18 elements. Let's see the numericals. What is the subshell? What is the subshell? Whether it is S, P, T and F, in which the last electron mean if the atomic number is 7, which is the last electron? 7 is the last electron of the first elements in the sixth period enters. Now from your sixth period, first elements, this is how the first period, second period, how many numbers of periods are there in the modern periodic table? 7. And how many numbers of group are there? 18. So we are supposed to see sixth period, the first elements. Suppose the sixth period, the first element is your X. Fine. So what is the subshell of that elements in which the last electron enters? Now student, the sixth period begins by filling the last electron in the shell with n is equal to 6. So sixth period, it contains how many numbers of shell? It contains 6 number of shell. As we know, whatever the periods the element possesses, it contains the same number of shell. So sixth period, the element containing how many number of shells? 6, and the last electron entered in the 6th shell. Okay, the lowest energy subshell of any shell is S. As we know, the lowest energy subshell of any shell is S, then P, then D, then F. Fine. And this shortcut is there. First element of any of the period belonging to the first group, yes or no? Second elements of any period belonging to the second group. As we know, first and the second groups, they are S block element, yes or no? Yes. First and the second element of the group belonging to S block. So the lowest energy subshell of any shell is S. So therefore the last electron of the first element in the sixth period enter the subshell 6s. Fine. Sixth period, first group. So the last electron of the first elements in the sixth period enter the 6s subshell. Here is the next question. How many elements are present in the sixth period? Explain. As we have studied the number of subshell in which the electron enter, its addition will give you the elements present in the respective periods. As we know, the sixth period begins by filling the last electron in the subshell 6s. Fine. And end by completing the subshell 6p. First electron, the sixth period begins by filling the last electron in the subshell 6s and ends by completing the subshell 6p. So therefore, as per the Orville principle, the sixth period had the subshell fill in an increasing order of energy as 6s, 4f, 5d, 6p. As we have studied in Orville principle, how the electron has been filled with respect to the increasing order of energy. So, the sixth period has a subshell filled in increasing order of energy as 6s, 4f, 5d, 6p. So, the maximum capacity of electron of this subshell for 6s, it is 2. For 4f, it is 14. 5d, it is 10. 6p is 6. How? For 6s is 2 because s containing maximum 2 electron, f containing 14, d containing 10, p containing 6. We have studied this thing very well in our previous lecture. You are supposed to see each and every lecture so that the basic concept should be clear. So the electron capacity of these subshell are, for 6s it is 2, 4f it is 14, 5d it is 10, 6p it is 6 respectively. Therefore, the total numbers of elements in the sixth period are added 2 plus 14 plus 10 plus 6. It gives you 32. What is the answer? 32. So here student, how many elements are present in the sixth period? 32 elements are present in the sixth period. In this way, you can find out the numbers of elements in any of the period. As we have studied in detail, electronic configuration of the first element, each and every elements. Electronic configuration of second period, third period, each and every elements we have studied. You are supposed to take a book in your hand, a pen, and scribble it. Write down the electronic configuration of the elements of each and every periods. It will be easy for you, and you can write down the electronic configuration of any elements from the modern periodic table. In short, a period begins by filling of one electron to the s subshell. Obviously, whatever the period is there, the electron will fill in the s subshell of a new shell and end with an elements having complete octet. Okay, except for the first period where it is duplet. Rather, all the periods start with s subshell, filling of electron to the s subshell of a new shell and ends with an elements having complete octet corresponding to the same shell. If it is fourth period, 4s, it will start with 4s and end with 4p. Between these two ends corresponding to s and p subshell of the valence shell, the inner subshell DNF are filled successfully. Find between any of the subshell S and P subshell, what is their DNF? So D and F subshell will fill successively according to the Orville principle. You are supposed to know the Orville principle very well. I am repeating it again, student. You are supposed to know Orville principle very well. It will be easy for you to write down the electronic configuration of any of the element from the modern periodic table. So here, student, we have completed the electronic configuration of elements in first period, second period, and so on. You're supposed to write down the elements, its atomic number, and write down the electronic configuration. It is a homework for you, student, to write down the symbol of the elements. From the symbol, you're supposed to know what is that element and write down its atomic number. Based on atomic number, write down it electronic configuration for the first period, then move toward the second period, then third period, and so on. It will be little bit hard for you in the starting, but later onwards as you move, it will be very easy for you and you will become an expert. Till then, take care, study well. Thank you. Allah Hafiz, student.